Alright, these examples are from IXL L12. A lot of you finished this last week in class, but some of you did not. I know a lot of you were gone, so I'm going to go over a few examples just in case there's any questions about it. The first question is, what is the domain of this function? So domain has to do with the x values. So my first point I can see is right here at x equals 0, and then all of my x's are greater than that. So this would have to be x is greater than or equal to 0. Okay, because of this underline, x is greater than or equal to, that means that this point right here is closed in and it can actually equal 0. Otherwise, it would be this other example right here where it could not equal 0. Okay, next example. So now I want to know the domain and range. So domain is your x values and range is your y values. So let's start off with the x's. Here's my starting point, and I can tell it's at x equals 4. And then all of my x's are getting bigger than that. So I know that for my domain, my x is greater than or equal to 4. Alright, now I'm going to switch and do the range. So the range are the y values. Once again, I can look right here at the same point, but this is when my y equals -5. So for my range, my y is equal -5, and they're going this direction still. But if I'm looking at it as far as the x-axis goes, all of these values are less than -5 since the graph is going down if I'm talking about the y's. So this would have to be y is less than or equal to -5. So then I would just select that on my answer choice, which looks to be the very first one. Okay, next example. So this time they took away the graph from you, and you have to either think about what would it look like if I graphed it, or if you have your calculator, just pull it out and graph this function. So if you don't have your calculator, or you could just think about, well, what would this graph look like? I know that my original square root graph starts at 0, and then it has this general shape to it. So this new transformation of that looks like I've been adding 1 to the x. And remember, if I add a number inside the radical, it's actually going to make it go left that many units. So if I were to graph this, it would start at -1 and then have the same shape. So this is whenever your x is at -1 and your y would still be at 0. So they want to know, what is the range? Remember, range is your y values. So my y starts at 0, and then all of the y's would be greater than that, because on the y-axis I'm looking at positive values up here. So my y's would be getting bigger as the graph goes on this way. So this would be y is greater than or equal to 0. Alright, last example. Okay, same thing. I can use my transformation rules, or just get your calculator out and graph it if you need a visual of what that graph looks like. So on this one, I can see that I have a vertical stretch. It's been moved left 3, and it's also been moved down 5. So if I were to graph this, let's just start with where the initial point would be. Instead of starting at 0, 0 like the original square root of x, my new graph to match this one that they gave me would have went left 3 and down 5. So I would go left 3 and then down 5. Maybe somewhere about right here. Okay, also this 5 out here tells me that this graph has been stretched up, so it's getting skinnier. So it looks something like this. You don't really have to worry about the shape of it. All I need to know is if it's pointing up or pointing down. So let's just start with the domain, which is the x values. Okay, if I'm looking at the domain, I'm looking solely at what is my x value at this initial point. So my x at this point was at -3. And then I need to figure out, well, are my x's greater than that? Are they going to the positive or to the negative? So from this point, it looks like my x's are increasing because they're going to the positive x-axis. So this would be x is greater than or equal to -3. All right, that's it for your examples.